Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. This talk is by Kilian Schulte, the author of the Jasper package. Jasper is a super cool framework for building websites with Dart. While you're at it, make sure to also check out the serverpod integration. Serverpod and Jasper make a mean combo. Let's dive in.
Hi, I'm Kilian. I'm a Flutter and Dart developer, and today I want to introduce you to Jasper, the first full-stack web framework that's completely written in Dart. I want to start a little bit with Jasper's history and how it got here, and along the way explain what even is a full-stack web framework and why do we need it. I myself started as a web developer, and I was developing different websites for different clients. And of course, I was using JavaScript and JavaScript frameworks. But when a friend introduced me to Flutter and Dart, I was very happy to leave JavaScript behind and journey into mobile development. But at some point, I found myself back at needing to write a website. And as many Dart devs do, I really didn't want to go back to JavaScript. So I was asking myself, is there a way to build websites with Dart? And that was around the time where Flutter Web started coming out. So of course, I also looked at that. And I'm sure by now you heard the mantra that Flutter Web is only for web apps. And without going too much into that, I'm just going to say this. Flutter Web was never and will never be the right choice for building normal websites. So any kind of landing page, blog, documentation, forums, social media, and anything that needs SEO or is content driven. So the vast majority of the web. And that's all what Flutter Web is not for. So still a lot of Flutter devs would like this to be the case, myself included. Two of the top issues in the Flutter repo are actually about SEO, which Flutter is inherently bad at, and server-side rendering, which Flutter will never be able to do. So it's not Flutter's fault because it's not meant for this. But what can we do actually? And as I found out, there is actually a way to write websites with Dart, and it's pretty simple. You create a new Dart project, set the template to web, and you have a website. You still have to write all your HTML and CSS files like normally, but instead of JavaScript, you write Dart code. And inside that Dart file, you can access all standard browser APIs like you would with JavaScript and, for example, change the text of an element. And while it's great that we can do that with Dart, this isn't really what we want. I mean, it works, but it's really basic. There is no widgets, no compositing of UI, and most importantly, no declarative rendering. Because all browser UIs are imperative. So after seeing this, I started doing some experiments. I tried to design a Flutter-like widget system with declarative rendering and compositing and so on, while still using Dart Web and still rendering normal HTML. On first look, you might just think it's a Flutter widget you see here. And spoilers, that's intended. You have your UI class, there are stateless and stateful variants, and you have a build method where you return and compose other UI elements. But on second look, there are of course some differences. First, it's called component, fair enough. Secondly, the primitives you return in the build method are not containers or columns. Everything here is a DOM component. And these represent the actual HTML elements that the browser renders. And thirdly, the build method looks a bit weird, right? It returns an iterable, so not a single component, and it uses sync and yield. And sync and yield are basically just syntax sugar for returning multiple elements. You could also just return a list here. And I made this design choice because in HTML, every element can have multiple children. So limiting the build method to only one return child would be a pretty huge limitation. So when we now render this out, this is what we get. Clean and normal HTML. More specifically, Jasper creates the browser instructions that result in this HTML. Because remember, all the browser APIs are imperative. And this is also the core function that Jasper does. It transforms your declarative UI code into imperative browser instructions. And it does that in a very optimized way, with as few instructions as possible to increase the performance of your site. To understand how this works, let's look one more time at Flutter's rendering system. Remember, we have 3 layers in Flutter. We have the widgets that configure an element, which create and update render objects. And the render objects are the ones that then actually paint to the screen. For Jasper, we also have 3 layers. We have the component layer that configures elements, and the elements then create and update DOM nodes, which are the native way the browser represents HTML elements. And of course, this skips over a lot of detail, but it should give you at least a general idea of what's going on under the hood. And if you now think, well, that looks suspicious, as if someone just copied over Flutter's widget architecture, well, that's exactly what I did. And it saved me a lot of work, and I think it shows how great it is to have an open source project like Flutter. Now, where are we? I, at this point, have built an experimental prototype, and I could have published this now to pub.dev, right? But when I talk to people, I found one problem. We as Flutter devs are really spoiled by having a really high quality framework with super great developer experience, lots of great tooling, an awesome ecosystem, and so on. And that's amazing for Flutter, but it sets the bar really high. So I started thinking about more something that could actually make building websites in Dart viable. And for that, I started to build a framework. Now, obviously, there's a lot that goes into building a framework and way too much to cover in this talk. And by now, Jasper actually can do all of those things. But since this is a full stack conference, I want to focus on server-side rendering. Server-side rendering is the process of pre-rendering your website on the server before it is loaded on the client. And this only works because rendering here, again, doesn't mean painting pixels. It means constructing HTML. So the same component as we have seen earlier can be rendered in 2 ways by Jasper. Once during pre-rendering to a string that contains just HTML, and this can be then sent to the browser when a user requests your website. And then again rendered on the client into DOM instructions that then the browser uses to render out the HTML element. And you can see now how Jasper really is a full stack framework. The same component is rendered both on the server and on the client. Now there's one more thing regarding pre-rendering. Jasper actually has 3 modes it can render your application in, because no one said anything yet about when pre-rendering happens. And this can happen at 2 different times. First option is to pre-render already at build time. So either locally or in the CI. When you build your website, Jasper can go in and pre-render all your pages and output an HTML file for each one. This is great for static sites like landing pages or wherever the content doesn't change much. The great thing about this is you have now a purely static site that you can deploy to pretty much any web hosting provider, because you don't have a server. However, that also means you need to rebuild and redeploy your site whenever some of the content changes. This brings us to the second option, the server mode. Here you pre-render your page at request time. So when the user requests your website, at that time the page is rendered on the server and returned as HTML to the client. This of course gives you great flexibility over loading fresh content for every page. Think of something like Stack Overflow, where it's a very content-driven site and SEO is also essential. But the content changes really often, like you can't redeploy Stack Overflow whenever someone posts a comment. Of course, with this option, you have an actual server running that you need to host somewhere. And for completeness, the third option is just no pre-rendering. You can also just use Jasper purely on a client to build something like a single-page site. And this concludes the early development history of Jasper. I published the initial release of Jasper now almost 2 years ago, and I dug out this old Reddit post I did back then. And I was really surprised to find out that by now it's the top most upvoted post in the subreddit. For me, this just shows how much interest there really is in something like Jasper. Now let's finally look at Jasper in action. I'm going to show you how I built this site. It's a collection of Dart quotes, and it has a list and then a separate page for each quote. And you can like that quote and get this nice confetti animation. The page is built with Firebase, both on the server and on the client, and has really good SEO performance. Now let's start with creating a new Jasper project. After giving it a name, we need to select the rendering mode. And since I want to build a pre-rendered site, but I also don't want to redeploy whenever some of the quotes change, I'm going to select server mode. Then I need to enable some additional options. Most of them you can just leave at the recommended option. I'm going to select routing here because we want to route between different pages of our site. And we don't want to embed a Flutter app, but we do want to use Flutter Web plugins. And this is a special capability of Jasper, where you can actually import Flutter plugins in your Jasper app. And this is enabled by Jasper's special compiler pipeline. So after that, Jasper creates a project for you and you can instantly start developing your website. For server mode, your main entry point is main.dart. Here you initialize some options and call run app. Then we provide a document. Document is a special component that gives you a basic structure like the head and the body tags. Now, additional to a title, we want to add some SEO meta tags like a description and a language. Additionally, we need to add some styles here. And Jasper lets us do this right from Dart. You don't need to touch CSS here. Additional to some basic styles, we're also adding some fonts. And this will now be rendered by Jasper to normal HTML doing pre-rendering. And this is what the output is. It's just normal CSS, but you don't need to write it yourself. Now, let's look at our app. The app is a stateless component that has a normal build method, and in here we define the router. This comes from the Jasper router package, which is one of the core packages that Jasper has. And we define two routes. One is for the homepage and one is for the quote page. And for the quote, we're going to add this quote ID parameter to the URL that we can use to load a specific quote from Firebase. Let's start with the homepage. We're going to yield a header here with the quote symbol and a title. And then we want to return the list of quotes. Now, before we continue building this UI here, we need to think about how we're going to load this from Firebase. And we are still on the server here. All the components so far have been rendered purely on the server. So we also need to access Firebase from the server. We can do that using the Dart Firebase admin package. Here I'm just using a singleton for the service, but you can use, of course, a service locator or any state management you want. Now, after some initialization, we're going to write the load quotes function. And this loads all the quotes from our Firebase collection and returns it as a list of quotes. Now, this function is asynchronous, but all build functions need to be synchronous, right? Well, Jasper allows an exception to this. On the server, you can actually write asynchronous build functions. This will wait with the pre-rendering until all the data is loaded, and only then continue and render out your site. Here we're going to use the async builder component. It's the same as the builder in Flutter, but it has an asynchronous build function. So we can use await here and call our load quotes function. After sorting the quotes by the like count, we can iterate over them and return a list element for each one. Inside the list, we can link to the quote page of that quote. And that's already our homepage done. And remember, we didn't touch any client-side code here. So if we look now in the network tab of that page, there is no JavaScript. And this is because, well, we didn't need any interactivity here. So we don't also need any JavaScript. So now let's look at the code page where we do want some interactivity. Now we also want to load some data here. So this component is also async. Inside the asynchronous build method now, we can call again await and call a function of the Firebase service. And we're going to write this function later, but for now we just assume it returns a quote given its ID. We then build the markup again. We return a quote container where we display the quote and the author, and we also want to display a like button that the user then can press. First, let's look at the get quote by ID. This again uses the server-side Firebase package. One thing to note here, it's returning a stream, not a future. And why this is, we're going to see later. But for now, we just need to make sure that we are actually handling the stream correctly. So we need to add the .single getter to get the single element that we are returning here. Now let's look at the like button. The like button gets the ID and initial count that we have loaded earlier. And it now uses the stream builder to also call the get quote by ID function. This is because on the client, we want to get continuous updates. Whenever the like count of the quote changes, we want to update this button. And inside the stream builder now, we get the count and whether the user has liked it, and then return the button that shows the count and also an icon that, depending on whether the user has liked it or not, has an active or an inactive state. Now, I said we want to make this interactive on the client, but this is still a server-side only component. To make it also render on the client, the only thing you have to do is add the add client annotation. This component is now compiled by Jasper to JavaScript and also included in the page when loaded. And now we have our first full stack component. The like button is both rendered on the server and on the client. But there's a problem here, right? We're still using our Firebase functions that are server-side only. Because in here, the .firebase admin package is not working on the client and it will throw a compilation error when we try to. To make that also work on the client, we need to tell Jasper to only import this package on the server. And we do it like that. Now Jasper will generate all the code that makes this work on the server and also ignore these imports on the client. One additional thing we need to do here is to make sure to actually only use this on the server. Now the next thing would be to add the same logic also on the client. And here we're going to use the Firebase Flutter plugins. Those are of course only available on the client now. So we can use the same system to only import the Flutter plugins on the client. And now we can extend our method to include the client-side Firebase logic to subscribe to updates of this one quote. And this is now also why we chose the stream here. Because on the client, we want to get continuous updates through Firebase whenever the like count of the quote changes. Now, there's one more thing we need to do. While the button still updates automatically on the client, it's not clickable yet. So we need to add the onClick handler to the button. And we just assume we have this method here now to toggle the like count that will go in and update it in Firebase. Additionally, we want to show this cool confetti animation we saw earlier. And for this, I chose to integrate a JavaScript library. I found this on npm, the JavaScript package repository, and I'm going to show you how to integrate this now with Jasper, exemplary for basically any JavaScript library. First, we need to add the script tag we see in the documentation to our page. And we can do this in the code page like you see here. After that, we're going to use JavaScript interop. This is new in Dart 3, and allows us to bind to the JavaScript objects from our Dart code. Additionally, I'm going to add some functions that make this easier to use. And now we can write a confetti service and use this JavaScript library. And notice again here, we are importing the interop part of the library only on web, because JS interop is of course not supported on the server. And with this, we have our finished page. And that's everything. We have now built a fully functional, full-stack website purely in Dart. I know that was quite some stuff, so I welcome you to check out the site yourself and see the code on GitHub. I hope you got an idea of what Jasper can do and how you can build amazing websites purely in Dart.